Okay, so today we're going to continue on with section 2. Today we're going to talk about the negative exponent portion of section 2. So negative exponents and dividing with exponents. So yesterday we saw when we multiplied with exponents, you add them. Today when you divide exponents with the same base, we're going to be subtracting the powers. Now, but before we get into the division, let's talk about a negative exponent. When you have a negative exponent, what you might help you to think about is think about reciprocal. A negative exponent does not make the answer negative. It turns it into a fraction or a decimal, depending on what you're asked to do. For these, we're just going to keep them fractions. So when you see a negative exponent, either think reciprocal and you flip it to its opposite spot. Okay? Or if it's a base with a negative exponent, you're moving it to the bottom of a fraction. So for this first one, this a raised to the negative n power, if you want to think of it as a reciprocal, you could put a 1 under it and then flip it upside down. And then you make the power positive. Or just think of the negative sign as becoming the fraction bar, and then you put it under a 1. Now, if it's already a fraction and it has a negative power, you just move it to its opposite spot. So again, if you think about reciprocal, a to the negative n power, we can flip this to its reciprocal, make it positive, and then this would just simplify. Anytime you have a 1 in the denominator, it just becomes a whole number. So let's look at maybe some examples with some numbers. So let's say we have 5 to the negative 2 power, and I ask you to evaluate it. So if you want to think reciprocal, we could add a 1 to the denominator, and then we flip it and make the power positive. And then if it asks you to simplify that 5 squared, it would become 1 over 25. If the negative is already in the denominator, let's say it's 1 over 5 to the negative 2 power, again, you can think reciprocal, flip it, turn the power positive, and now we would simplify. Becomes 25 over 1, and it simplifies to 25. So remember, a negative exponent does not make the answer negative. It makes it a fraction. Or if it's a fraction, it turns it into a whole number. So sometimes it helps to think reciprocal. Now, on to the division. When we have a division problem, and when the base is the same, all we do is take the powers and we subtract them. So let's take a look at it with some numbers. Let's say it's 2 to the 7th divided by 2 to the 5th. I'm going to go ahead and subtract. Do not divide the 2's. The 2, the base stays the same, and then you subtract the powers. This would become 7 minus 5 is 2, 2 squared, and it's 4. Now let's say it's the other way around. It's not always going to have the bigger power on the top. Let's say it's 2 to the 5th divided by 2 to the 7th. We're still subtracting top minus bottom, so 2 to the 5 minus 7 power gives me 2 to the negative 2. I now have a negative exponent. I need to make that positive, and I move it to the bottom of the fraction. And then now I can simplify, and it simplifies to 1/4. You don't have to figure out what 2 to the 7th is and 2 to the 5th and then divide them. Just subtract the powers. Question?
Are a base and a coefficient the same thing?
Well, let's say we have something like this, and we're going to see some examples. Let's say it's 5x to the 5th divided by 10x squared. So the 5 and the 10 are the coefficients, but the bases here would be the x's. Does that make sense?
Yes.
Okay, so then here what you would do is you would simplify the fraction, the 5/10, to 1/2, but then for the x's, we're going to subtract the powers because this is where we have the same base. And then it would become x to the third. And you could even write this as x to the third over 2. These both mean the same thing. So when you subtract, if the answer to the subtraction of the powers is positive, it goes in the top of the fraction. If it's a negative answer, then it would go in the denominator. Good there? All right, now, let's say you blank out and you're like, oh my goodness, what do I do when I divide exponents when the bases are the same? And you forget, you add, you subtract. Again, what you could think of this logically. So if you took 2 to the 7th and you wrote out 2 7 times, and then 2 to the 5th on the bottom, then you could simplify. 2 divided by 2 is 1. 2 divided by 2 is 1. 1, 1, 1. And then you just multiply what was left over that didn't cancel. And then you can get 4, the same answer we got when all we did was subtract the powers. The same thing would work if it were this problem, where 2 to the 5th was on the top and 2 to the 7th on the bottom. Again, simplify it. A 1, a 1. Now, remember that when it cancels, it doesn't disappear. Anything divided by itself is 1. So in the numerator, we were left with a 1, and in the denominator, 2 times 2, and it's 4. It's a lot easier just to subtract the powers, but if you ever blank out, expand it and give yourself a visual. Just remember that when you have a negative exponent, it does not make the answer negative. It makes it a fraction. Okay, so for the first one, we have 4 raised to the negative 2 power. So again, it doesn't make it negative, it's going to make it a fraction. So if you want to think of this as being 4 to the negative 2 over 1, and then flip it and make the power positive, and now we evaluate 4 squared, and it's 1 over 16. Then for the next one, number 2, again, all we're going to do, if you want to put a 1 under it, so then you can flip it, you can. You don't need to. And then it becomes 1 over x to the third. Now the next one, be very careful. Notice, and this was sort of like what David was asking, notice the power is only on the x. It's not on the 2. So when we go to do this, the only thing that's moving to the denominator is the x. So we would leave the 2 on the top, and the x to the 4th moves to the bottom because the power is only on the x. Now, if it were in parentheses, 2x, and if this entire thing was raised to the negative 4 power, then I would move everything to the denominator, and then I would have to evaluate 2 to the 4 power would go on the 2 and on the x. So this would actually simplify to 2 times 2 times 2 times 2, which is 16 x to the 4th. So just remember, if it's in parentheses, you're applying that power to everything. But if there's no parentheses, it's only up above whatever number or letter it's next to or above. Let's try number 4. Now this one's already a fraction. So this is where reciprocal might pay off. So if you have an entire fraction raised to a negative power, flip it to its reciprocal and make the exponent positive. Now we actually have to figure out what 5 halves cubed is. And what this is going to happen is you could pull it apart, put the exponent of 3 on the 5 and the 2, and then it becomes 125 over 8. I'm okay with you leaving it improper. You don't need to make it into a mixed number. Now, if you ever blank out, you could also have done 5 over 2 times 5 over 2, since it was the third power. Write it down 3 times, and then multiply straight across. The next one, we've got parentheses. So we're going to move the whole thing underneath a 1. So -4 squared. Notice my exponent is even. So this tells me it's going to be a positive number because a negative times a negative is a positive. So this ends up turning into 1 over positive 16. Mm-hmm. Look at number 6. It looks just like number 5, but notice this time there's no parentheses. So remember, this power of the -2 is only on the 4. It's not on the negative sign. So you can either think of this negative sign as being a -1, and then times 4 to the -2. And then we can, again, take the 4 to the -2 power. It's going to go to the denominator, and then we can simplify. So -1 over 16. Now, one other thing to remember is if ever you have a fraction, and if there's a negative in the top or a negative in the bottom, or if the negative sign is out in front of the whole fraction, all 3 of these are the same answer. However, if you have a -1 in the top and a -16 in the bottom, remember a negative divided by a negative, and this would turn into positive 16. So just be aware of when you see different things like this. One negative sign, whether it's in the top or the bottom or in front of the whole fraction, just means it's a negative fraction. More examples. So here for number 7, again, be careful. The only thing that's being raised to the -3 power is the y. The x has the assumed power of 1 here, so it's going to stay on the top. So it's going to become x, and then the only thing that moves to the denominator is the y to the 3rd. So for number 8, if you have coefficients in front of your exponents that have the same base, we're just simplifying those coefficients. So I'm going to simplify the fraction 4 over 16, and that part's going to become 1/4. Now for the x's, I'm dividing because they're the same base. So I'm going to do x to the 3rd power and then subtract the x to the 4th. I get x to the -1. After I do the subtraction of the exponents, if my new power is negative, I write it in the denominator. If this were a positive number, then I'd write it in the numerator. So this becomes 1 over 4x. The next one. All we're going to do here is rearrange the variables that have the negative exponents. So let's go ahead and we're going to move this one and this one to the denominator. The 4 and the y squared, they're staying in the numerator. Now, if that were a -4, it still would stay in the numerator. It doesn't have a negative power. So this becomes 4. Let me not do it in highlight. So 4 y squared, and then I'm moving the x to the 3rd to the denominator and the z to the 4th to the denominator. Let's try number 10. Again, all we're doing now, for this one, we can go about simplifying this one 2 ways. We could either switch the spots, or if you'd rather just subtract the exponents that have the same base, we can do it that way as well. So let me show you both ways, and again, you can choose which way you want to do it. The first way I'm going to do it is taking care of all the negative exponents, and I'm going to make them positive. So what I'm going to do the first time is I'm going to move the x to the negative 2 power down, and I'm going to move y to the negative 3 power up. I'm switching the spot to make it positive. So the 3 is already there, and then I'm going to keep the y to the 4th, but then I'm also moving up the y to the 3rd. And then the x to the 4th was in the bottom, and I'm going to move the x squared down. Now we're going to use what we learned yesterday, the multiplication. So this is being multiplied, so I add the powers. So then this becomes 3y to the 7th. And then I can do the same for the bottom, add those x's because they have the same base and they're being multiplied. So this is one way to do it. The other way is, since you see that it's a division problem, let me rewrite it. Now, this is where you need to be very careful with your signs. We're using our rules for subtracting integers. Your teacher might have taught you keep, change, flip, or stay, change, change, whatever it was when you subtract integers. So if you don't want to move the negatives, what we can do is recognize that we have two exponents here with the same base. And what we're going to do is we're going to subtract their powers. So for the 3, it's staying in the top. But I'm going to do x to the negative 2 power minus 4. So when I subtract negative 2 minus 4, I get negative 6. Because it's a negative power, it's going to the denominator. Then I'm going to do the same thing for the y's. Y to the 4th minus negative 3. Keep, change, flip this, becomes 4 plus 3, and it's y to the 7th. Because the power is now positive, the y goes in the numerator.
So because of keep, change, flip, does that mean that we should never have an answer with a negative exponent?
Once you do keep, change, flip, well, we did. We got a negative 6, but then when I place it back into the answer, it goes in the bottom. So you shouldn't have any negatives in your answer. You need to place them in the appropriate spot. Does that make sense? Okay, so notice I got the same answer using either technique. I don't care which one you use, just find the one that's going to work the best for you. All right, so for number 11, it's division. So remember, when you divide exponents, we subtract the powers. So 5 raised to the 9, and then we're going to subtract the 7, becomes 5 squared, and it's 25. For number 12, same base, subtract the powers. X to the 14 minus 10 gives me x to the 4th power. Then for number 13, notice it's the same thing, but now they switched places. I'm still subtracting 10 minus 14, but now when I do 10 minus 14, I get negative 4. I need to make this exponent positive, so now I'm going to make it the fraction. And it'll be 1 over x to the 4th. So the instructions will say simplify. None of your answers should be left with any negative exponents. Now number 14, we're still subtracting the powers because we have the same base. So 7 to the 5th power divided by 7 to the negative 3, we're subtracting 5 minus negative 3. Do your keep, change, flip, or your stay, change, change, whatever you learned. And it becomes 5 plus 3, so it becomes 7 to the 8th power. Now, if the instructions said to evaluate that, you'd actually have to do 7 to the 8th power without a calculator. But we're going to just leave it like that for now. For the next one, we've got some coefficients that we need to simplify. I'm going to simplify the 15 over 5. 15 divided by 5 is 3. And then now I'm going to take care of the exponents because the x's have the same base. So I'm going to be doing x to the negative 4 divided by x to the negative 8. We're subtracting those powers. So negative 4 minus negative 8, again, do a key flip change, becomes negative 4 plus 8, and I end up getting positive 4. So then this becomes x to the 4th. So 3x to the 4th. Now, if you'd rather flip your negatives, you could have done that as well. So if you would have rather taken the original problem, you still would have to simplify the coefficients to a 3. But what you could do is you could have switched the places. But in the end, you're still subtracting the powers. So you would still have had to do 8 minus 4, but then you wouldn't have had to deal with those negative signs. So then 15 divided by 3 again, or divided by 5 is 3, and then x to the 4th. Either way. Yeah. Okay, so for number 16, you can either choose to move all the exponents that are negative, make them positive, and then deal with it, or just subtract the exponents that have the same base. So let me go ahead and do the moving part first. So let me just leave the 15 and the 25 alone for now. So the a to the 5th is going to go to the denominator, but the a squared is going to the top. And then the b to the 1st goes to the bottom, and the b to the 4th stays in the bottom because it was already positive. So the only things I were moving, I was swapping the places of the a to the negative 2, a to the negative 5, and then I also moved the b to the negative 1 down. The b to the 4th stayed there. Now, I still got to use my rules for multiplying exponents and dividing. So let me go ahead and simplify the 15 over 25. This is going to reduce to 3/5. Then for the a, I need to do a squared minus, or divided by a to the 5th, so I subtract. It gives me a to the negative 3. Because it's a negative exponent, it's going to the bottom. So it'll become a to the 3rd power in the bottom of the fraction. And then for the b's, they're already in the bottom. All we're doing to those is multiplying them. This one assumes a 1, so it becomes b to the 5th. So it'll become 3 over 5 times a to the 3rd, b to the 5th. Now, if you'd rather just deal with the exponents to begin with, let me rewrite the problem. So if instead you just want to simplify the fraction, that becomes 3/5. And then for the a's, instead of moving them, just do negative 5 minus negative 2. Keep, change, flip it, and you get negative 3. And then that's how you know to put it in the bottom and make it positive. And then for the b's, same thing. You're going to do negative 1 minus 4, which gives you negative 5. So b to the negative 5 tells me write it in the denominator.
Sorry, could you just do the a's in the first way? Because I got lost for a second. How you got through using the first method that you were talking about?
By moving them?
Yeah.
Okay, you can do whichever method you want.
No, I just want to know.
Oh, what I did?
Yeah.
Okay, so what I did on the first method, I switched to make a to the negative 2 positive, it goes to the top, and a to the negative 5 to make that negative 5 positive, it goes to the bottom. So what I did initially first is I took all the negative exponents and I moved them if they were negative and made them positive. So what I had to move was the a to the negative 5 to the bottom, b to the negative 1 to the bottom, and then a to the negative 2 to the top. The b to the fourth was positive, so I left it alone. You follow that? And then now I can divide these by subtracting 2 minus 3, or 2 minus 5. And that's how I got negative 3, which means it goes to the bottom.
Oh, thank you.
Good. And you're welcome. And then these we just add together because they're positive and they're in the bottom. Okay, so for 17, now we have a fraction raised to a negative power. Now again, you can deal with this however you want. What I'm going to do first is just deal with the negative sign. And what I can do here is flip it. So I'm going to go ahead and flip the fraction, and it's going to become 4a to the negative 3b to the fourth, negative 3ab, and now my power is positive. Now, what I can do next is I can move, if you want to move the negative exponent to the denominator, I can do it that way. So it becomes 4b to the fourth over negative 3a times a to the positive 3 now because it moved, and then just the b. Now I still got that power of 2 on it. And these are going to be the types of questions you're going to get that are going to be more complicated on your test or quiz, or your quiz next week. Now, I could then now simplify the a's, and I could simplify the b's as well. Let me go ahead and put that back. So this becomes a and then a to the third. So I'm going to subtract the b's, and I'm going to add these a's. So then now my fraction is going to be 4b to the third, because I'm doing 4 minus 1. And then I'm going to add the a's, a to the fourth. Now I need to still raise this to the second power. So then the power of 2 is going to go to the 4, to the b, to the negative 3, and to the a to the fourth. So 4 to the second power is 16. B, this power to the power you multiply. Negative 3 squared is 9. And then a to the fourth power to the power becomes a to the 8th. That's one way you can deal with it. The other way is don't flip it first. Simplify what's in the parentheses, then square it. Either method. So if you wanted to do it the other way, what you could also do is take care of all the stuff in the parentheses. So let me go ahead and do it this way. So another way you could do it is take care of and get your A's together and then get your B's together. So another way to do it is we're going to divide. So a to the first minus negative 3 becomes a to the fourth. And then for the B's, this will become b to the first minus b to the fourth gives you b to the negative 3. So then what we could write here is negative 3, and then the a to the fourth is in the top, and then the 4 is in the bottom with the b. And now it's still squared. So all I did was simplify the bases that were the same, and this is a negative. So now what I'm going to do is flip it to the reciprocal. So 4b to the third, negative 3a to the fourth, and now my exponent is positive 2. And now I can square everything that's in here, and it'll turn into that. Either method, it works. It doesn't matter how you want to do it. We can do the same thing on 18. For 18, I'm going to go ahead and simplify just like I just did. I'm going to take care of my x's first. Now notice this one. Remember, anything divided by itself is just 1. So this becomes a 1. Now, there's no y's to subtract and no z's. So all I have to do is switch the spots for the y and the z. So I could go ahead and I could also simplify -3/9 and make this 1/3. I'm going to move the z to the top and move the y to the bottom. And I still have the -3 power. Now I'm going to flip it to its reciprocal. So 3y squared over -z. And now it's a positive 3 exponent because I flipped. And now I'm going to cube everything in there. I need to cube the 3. And I need to cube the y squared and cube the -z. So then this will become 27 y to the 6th over -z cubed. Now, you could have also moved the negative sign to the top and make the z in the bottom positive, or just move the negative sign out front. Now, if you prefer to flip and then apply it, you can do that as well. It doesn't really matter.